Mathematical Physics, Conservation of Energy. This chapter puts together a lot of the concepts we've already gone through in this unit. So we're going to start by reviewing what a system is, work, and also the conservation of energy. We will then talk about gravitational potential energy and kinetic energy as they relate to each other, and then we will be finding height and velocity of different objects using the concept of conservation of energy, which frequently is easier to use than the kinematics that we use. Remember the velocity, the displacement, the acceleration equations? Sometimes it can be done quicker and easier using energy and the conservation of energy. System work and conservation of energy review. System and environment. We will be dividing the universe into what we want to look at and everything else. It's pretty hard to solve problems that involve the whole universe, so we're not even going to try. Now, we did cover this in the What is Energy chapter, but this is so key to understanding energy and physics in general, we're going to go through it again. So here we have the universe, and here's going to be our system, which is what we want to look at, and then everything else we will call the environment. System and environment. The little piece of the universe that we look at when we solve a specific problem is called the system. And that's right over here. See, it's isolated there by the dashed lines. A system can consist of one or more objects in a region of space. We put an imaginary boundary or frame around the system. Everything outside the system boundary is called the environment. And that's all the stuff in the light blue color. Systems can be closed or open. When the system is not affected by things in the environment, and again, here's the environment, all of this stuff in gray, we call it a closed system. It's as if the system was in a universe by itself. Objects can't leave, no other objects can get in, and no outside forces affect anything in the system. When a system can be affected by the environment, we call it an open system. And in this case, particles can come in, we can have objects leave, and some outside forces, not all, can affect the objects in the system. Now, we're still focused by the objects inside the system, but they can interact with others outside, and that will be our open system. By separating the system from the environment, and together they make up the universe, we can make a problem solvable. When we define an appropriate system for our problem, we can isolate the forces that are within from the forces that act on the system from the environment. Energy can be changed from one form to another, like kinetic to gravitational potential energy or vice versa. However, the total amount of energy cannot be changed in a closed system. In an open system, the total amount of energy can be changed by applying an outside force to the open system. Work must be done by the external force to change the energy of an open system. Open system, external force has to do work. Work is an outside force outside the system that is applied to an object in an open system, and it changes its energy by moving it through a displacement or a distance. We're only going to deal with two forms of energy in this chapter: kinetic energy, the energy of motion, and gravitational potential energy, where you store energy due to gravity, and it's related to the position of the object. If the system is open, external forces can do work on the system. That is, work is not equal to zero. Therefore, the initial energy plus work equals the final energy. The energy of the system will change. It goes up by the amount of work if it's positive. And that's the first comment here. If the work is positive, W greater than 0, then the system's energy will increase. If the work is negative, for example, if you put the brakes on when you're driving a car, the work is less than 0 and the system's energy will decrease. If the system is closed, there is no work done on the system by outside forces. That's the definition of a closed system. So work is equal to 0. So when I have this equation here, work is equal to 0, you get initial energy equals final energy. The energy of the system doesn't change. We say that the energy is conserved.